Okay, the next section is about inequalities and solving them, writing them, and graphing them. And these are inequalities in one variable. So when we're talking about inequalities, we're talking about an imbalance. Something that's greater than 3 has an infinite number of solutions because it could be 3.1, 3.04, 3, anything greater than 3 all the way up to infinity, 4, 5, 6, 7, 8, and continue all the way up. So there's always multiple solutions instead of one. And I want to just remind you really quick, inequality. Don't worry about whether it's called greater than or less than. I've never understood why any elementary teacher teaches this. This is nothing more than a symbol of inequality. Where the open mouth is the greater value. Okay, whichever direction it is. I personally read it left to right. This says x is less than 4. Okay, this also says x is less than 4. I read it from the variable side, and I can read it actually left to right here and right to left there. I read it from the point of view for the variable. But don't think that you always have to read it 4 is greater than x. I mean, you can read it that way, absolutely. But there is no direction. It's both directions. We can look at it two different ways. All right. That's greater than, as far as like this is the greater than. Okay, x is greater than 4, right? Actually, x is less than 4. Ooh. Okay, sorry about that. It's late. No, I don't have an excuse. I don't know what the heck I was thinking. Anyway, when you have a line underneath, that is going to be less than or equal to, because if we're talking about x, x is less than or equal to, and you can have x is greater than or equal to. Okay, so whenever there's a line underneath. All right, so we're going to take a look at these. It says translate the sentence into an inequality. Okay, so let's start. It says the product meaning multiplication. Remember I said when you have see these words, look for the word and. This piece is on the one side of the multiplication, that's on the other. Is at most. This at most is the inequality. Okay, and I want you to think about it logically. If it is at most 27, does that mean that here's 27? Could it be 28 or could it be 25? Think about this. Is it above or is it below? If it's at most 27, this is the border. It has to be less than. Okay, so we are going to say less than. However, at most means it could also be 27. So the ending is 9x is less than or equal to 27. Next, it says write inequalities to represent the situations below. The cargo of the truck weighs no more than 2,200 pounds. So here you got your truck, okay? It's saying 2,200 pounds. It says the cargo weighs no more than. Again, ask yourself, what does that mean? Can it be more than or less? Does it have to be less than? And you can see it has to be less than. It can't be more than 2,200. So it says use W to represent the weight. So the weight has to be less than or equal to 2,200. In English, no more than also means equal to. It could be equal to. In the second situation, it says to qualify for the championship, a runner must complete the race in less than 40 minutes. Okay, that means, think about it. Does it mean the guy or girl or whoever could actually run for 40 minutes and qualify? No, it means that it can't be 40 minutes. It has to be less than 40 minutes. It says use T to represent the time in minutes of the runner. So the time has to be less than 40 minutes. Okay, moving on. Graphing an inequality. Okay. All right. A compound inequality. Compound just means more than one. Okay. Compound inequality. You get two different types of compound inequalities. You get a kind with an or, and sometimes you get one with an and. An and typically looks like this, where the x is between two numbers. So on the or situation, the way I personally do these is I just graph it. Like I don't really try to think of any tricks or anything. I just read the numbers. Actually, I don't think I'll make that 0. And I just read the inequalities and graph them. If this is -1, 0, 1, 2, 3, 4, 5, 6. I don't like that. I don't like that. Let me make it longer. 6, 7. Okay. Try to remember that whenever it's equal, it's a solid dot representing the fact that it could be equal. It could land on that spot. If it says x is greater than or equal to 6, it means that it can be equal to 6. Okay. And it's going to be greater than. Name a number greater than 7. Okay. 7, 8, 9, and go in the greater distance, greater than distance. Or x is less than or equal to 1. Find 1. It can be equal. It's a solid dot. All right. And less than. Name a number less than 1. 0. And there you go. I do it that way rather than say like, oh, if it looks like an L, you go in the left direction. So don't do that. I think you need to think about it. It's much better to think than to just use weird tricks. Okay, on the and situation, you could have 0, 1, 2, -1, -2, -3. Okay, what does it say? Read it from the point of view of the x. If you read it there, the little mouth is trying to eat the x. So x is greater than -3. So we're going to go to -3, and it's greater than or equal to. Sorry. So it's a solid dot, but it's greater than. What's the number greater than -3? 10. It's in that direction. Greater than means we're climbing up the number line. Okay, we're going to keep going, but it says x is less than 2. So here we are at 2. It's less than 2. That is an open circle. It cannot actually arrive at 2 because it doesn't have the equal sign underneath there. Okay. Next one, back to equations. The main thing about inequalities is that you remember when you multiply or divide by a negative number, you have to switch the direction of the inequality. I'm going to show you why. Math follows patterns. And especially those of you that are a little bit more advanced will appreciate this as well, just because it's kind of fun to see where some of these theorems come from or realizations. Remember, we just discovered math. It's not like we invent it, we just discover it. So check this out. We know that a negative times a positive is a negative, right? So let's take a look at this. So we go -2 times 3 is equal to -6, right? Okay. If we take -2 times -3, what am I doing? I'm losing my mind.